The title of this presentation is Why African Humid Period Took Place. The long-term climate change caused by Earth's precession. Africa was moist at 7,000 years ago. At that time, trade winds were shifted to the northern hemisphere. The trade winds moved the atmosphere from east to west during the day, but at night, winds moved from west to east by solar winds at backside of the Earth. So, the humid climate kept. The rotation axis rotates in a 26,000-year cycle due to the precession of the Earth. After BC 6,500 years, the rotation axis tilts east, and trade and westerly winds moved to south. Therefore, the westerly wind began to blow continuously day and night in North Africa, and desertification progressed. The tilt of Earth's rotating axis is maintained during in a year. However, the direction of the Earth's rotation axis rotates with a very long period on the precession of the Earth. According to the virial theorem, kinetic energy is equal to 1/2 of the positional energy in equilibrium. For example, as electron approaches to the nucleus of an atom, the rotational speed increases due to kinetic energy of 1/2 of the positional energy. When the boiled egg is rotated and grounded, it moves from the energy of rotation to the energy of gravity, so it rises. In the conventional theory, it has been explained that precession is caused by the tidal force of the Earth. The Earth's tides are the phenomenon that decreases the velocity of rotation, and the tidal effect does not explain the essence of the mechanism of precession. According to ancient Egyptian records about 4,800 years ago, the north celestial pole was located around Thuban. Hipparchos measured the angular distance between the Moon and Spica during the total lunar eclipse, because lunar eclipse occurs at the intersection of the ecliptic and lunar paths. He found that the measured angular distance was different compared to the astronomical catalogues created by Timocalus about 150 years before his time. Moreover, he found that the other stars were similarly misaligned. So, he concluded that this deviation was not due to the motion of the star, but because the vernal equinox point itself was moving. The center of the surface irradiated by the Sun moves along the same latitude due to the Earth's rotation. So, the weather is moving along the latitude and orbiting the Earth in a cycle of several days. The solar winds passing at high speeds through the east side of the Earth's atmosphere are more effective than the western deceleration effect. So, the solar wind is possible to explain why the atmosphere orbits the Earth faster. However, the reason that the solar wind does not reach the ground has been explained as geomagnetic prevents the solar wind in a conventional understanding. The true reason why the solar wind does not reach the ground is collisions with the molecule of atmosphere on the ground that the mean free paths is micron meters. As shown in Fig. 3, the solar wind collides with the molecules in the upper atmosphere. The solar wind has a rotation component of 1.89 km per second counterclockwise, and when it collides with the front of the daytime hemisphere, it becomes a trade wind. Trade winds blow clockwise near the equator in the daytime hemisphere, while solar winds blow counterclockwise over the night side. On the other hand, solar winds above 500 km per second passing east side of the Earth's high latitude move the atmosphere from west to east, so the entire Earth's atmosphere is moving from west to east faster than the Earth's rotation. Luzon Island in the Philippines has a rainy season from June to November, with squall in the afternoons or evenings. The squall in the evening is thought to be rained when the easterly wind of the trade winds collide with the westerly wind on the night side. From December to May, trade winds are replaced by westerlies, and Luzon Island is in dry season as the same as North Africa. At winter solstice of the precession as shown on left side of Fig. 5, westerlies blow from northwest at northern hemisphere during hundreds years, so the northern hemisphere becomes cold. The last ice age ended about 10,000 years ago. The Earth's precession gradually decreased the westward tilt of rotational axis, and the irradiation of the Sun in the period around the vernal equinox had shifted to the northern hemisphere side as shown in center of Fig. 5. So, the northern hemisphere was warmed at that period. At summer solstice of the precession as shown in right side of Fig. 5, westerlies blow from southwest side at northern hemisphere during hundreds years, so the northern hemisphere has become warm. There was a period when much of North Africa was covered with grass and trees. The solar wind blows in the tropics in the daytime, but at night the solar wind blows from the west to the east. During the day, the water vapor evaporated by solar irradiation moves from east to west. The water vapor is returned from west to east at night. So, the 7,000-year-old Sahara, where trade winds were blowing, was not dry. Africa's humid period has changed from a trade wind to a westerly wind since about 5,000 years ago. With the dryness of North Africa, humans gathered in the Nile basin, and Egyptian civilization was born. The shell mounds tell us the living of human during several thousands of years ago, and the location of the coastline. The sea levels in Japan rose from 6,500 to about 6,000 years ago. This sea level rise was caused by a decline in westerly winds together with global climate warming. Conclusion: Earth's precession affects millennial climate change and has been involved in human history. Thanks for attention.